Hello, this is Mr. Best. Welcome to Chapter 9, homework questions 79 through 86. Question 79. Unlike a straight edge, a ruler has measurement markings. With a ruler, it is fairly simple to construct a line segment of length 6 centimeters or a line segment with length 3 inches. But how can you construct a line segment of the square root of 2? Consider this as you answer the questions below. With a ruler, construct a line segment of 1 centimeter. So I made something that appears to be about 1 centimeter, hopefully, depending on how big your screen is, I guess. Part B, what about 1.4 centimeters? Adjust your line segment from part A so the length is 1.4 centimeters. Did your line get longer or shorter? And so I made one another little bit longer than that, and so 1.4 is longer than 1, so this would be 1 centimeter. This would be 1.4 centimeters. Part C, now change the line segment so that its length is 1.41 centimeters. So we've gone from 1 to 1.4 to 1.41, and so it'll be just a little bit longer than the first or the second one. And then D, Karen wants to draw a line segment. A line segment is exactly the square root of 2 centimeters long. Is this possible? Why or why not? So we probably have to think of this a little bit different than what's Karen's doing, because then we just have to go 1.414, 1.412, and then continue to go on. Since the square root of 2 is an irrational number, that decimal point just keeps going. So is it possible? It is possible, but we definitely got to look at this a little bit different. One way that we could do this is we could construct a hypotenuse for a right isosceles triangle. So we could go 1 centimeter, 1 centimeter. So this would be 1 centimeter, 1 centimeter, and then your hypotenuse, if you drew between those two, should be the square root of 2. And so that's one way that you could draw a segment that is the square root of 2 long. Once again, in terms of what we're looking at and trying to draw it by hand, it's always going to be a little bit difficult, but that's one way that you could look at it a little different than what Karen did, but still allows us to graph 1 and 1. We can do that, and then connecting those two in terms of a right triangle would give us that square root of 2. Question 80, describe a sequence of steps to construct an equilateral triangle. And so I have a possible response down here, and that is to construct a circle of any radius, then choose a point on the circle and mark off 2 radius lengths in each direction along the circle circumference. Connect the original point to each of the other 2 points. Question 81. The floor plan for Marina's local drugstore is shown at the right. While shopping one day, Marina tied her dog, Mutt, to the building at point F. If Mutt's leash is 4 meters long, what is the area that Mutt can roam? Draw a diagram and show all the work. So the dog is tied up right here, and it has a 4 meter long leash, and so you're going to see that the dog can travel 4 meters along each of that. So we're not going to have a full circle. We are going to have to, cut off this part of the circle, which is 120 degrees, and that is a third of a full circle. So 360 divided by 120 is going to give us 3. So that's a third of the full circle. So if we can figure out the area, it is looking for area. For the area of the circle, then we can take 2/3 of that, because the rest of the circle is 2/3. So let's go ahead and find the area. The area is pi r squared, with the leash being 4. That would represent the radius. So the area is 16 pi, but we need only 2/3 of that. So if we take 16 pi times 2/3 of that area, that would be 32 pi over 3. And so the total area that the dog can cover would be approximately exactly 32 pi over 3, but approximately 33.51 meters squared. Question 82, find the area of Marina's drugstore, and problem 9-81, show all the work. Alright, I've redrawn the picture a little bit here, and so we have the 3 different distances, and it is a parallelogram, or not a parallelogram, sorry, it's a trapezoid because we only know that one set of parallel lines. And this parallel line with this one, these are same side interior, so they have to be supplementary, so we know that's 60 degrees. And then we can potentially create a right triangle because we know we need to create the height here. So that's 90 degrees, so it looks like we're looking at a 30, 60, 90 triangle. We have the hypotenuse, so we know the short side is half of that, which would be 9. And then we know the height, or the long leg, is the square root of 3 times the short leg, so it'd be 9 square roots of 3. So the area for a trapezoid is 1/2 times the height, which is 9 square roots of 3, times the sum of the bases, which is 14 plus 20. So let's see. So 1/2 times 9 square roots of 3, 14 plus 20 is 34. So half of 34 would be 17. So 17 times 9 is 153 square roots of 3. So that'd be the exact area of the drugstore. But if we want the approximation for the area of the drugstore, 153 times the square root of 3 is approximately 265, and this measured in meters, so it would be meters squared. Question 83, compute the volume of the figure at the right. So we have the height, which is 4 feet. We need to figure out what the area of the base is. We do see that the radius is 3, so the area of the circle on the bottom is pi r squared, or pi times 3 squared. So the area of the base would be 9 pi. And then we have a height of 4, so to find the volume, we want to take the area of the base, so that's 9 pi times the height of 4. So the volume is going to equal 36 pi, and this is measured in feet cubed. And if we want the approximation of 36 pi, we can type in 36 pi into our calculator. We get approximately 113.10 feet cubed. And so that represents the volume of the figure. Question 84. Which has greater measure, an exterior angle of an equilateral triangle or an interior angle of a regular heptagon? Show all of your work. So the exterior angle of an equilateral triangle, the exterior angles add up to 360 degrees, so if we divide by 3, that means the exterior angle is going to be 120 degrees. So we're comparing that to the interior angle of a regular heptagon. So the regular heptagon here, we could do the same thing. We could find the exterior first and then take 180 minus that. So 360 degrees divided by 7 is approximately, actually, 51, we'll go 51.4 degrees. So to figure out, and this is going to be the exterior, so to figure out the interior, we will take 180 minus the 51.4 to get an approximation of 128.6 degrees. So which has the greater measure? That's going to be the interior angle of a regular heptagon. That's the one that has the greatest measure. Question 85, on graph paper, graph the line y equals negative 3/2 x plus 6. State the x and the y intercepts. So we know that the y-intercept is at 0, 6. And we know that the slope is negative 3/2. So let's graph the line, down 3 over 2, down 3 over 2. We also then identified the x-intercept by using the slope. So we now know the x-intercept is at 4, 0. And then we can graph the line based on those 3 or 4 points. So we've graphed the line, and we've also stated the x and the y intercepts. Question 86, multiple choice. A solid with a volume of 26 inches cubed was enlarged to create a similar solid with a volume of 702 inches cubed. What is the linear scale factor between the two solids? Well, let's first figure out what the ratio is. So we'll take 702 and divide it by 26. And that is equal to 27. Since this represents the volume, remember the linear scale factor is r. R cubed is the volume and how much it grows. So if it's r cubed is 27, then the cube root of 27 is 3. So therefore the linear scale factor would be 3, which is multiple choice letter C.